Hello and welcome to Washington Exec's video series. I'm your host, Amanda Ziadeh, and joining me today is Mark Russell. He leads technology and global engineering for Raytheon Technologies. Thank you so much for joining me today, Mark.
Amanda, thank you for having me. Appreciate it. Appreciate taking the time.
Of course. So Raytheon Technologies was formed this spring after Raytheon Company merged with United Technologies Corporation, bringing together two well-known aerospace and defense innovators. So Mark, I wanted to ask what we can expect from the combined company relative to technology, and what can you now do together that you couldn't do separately?
Well, Amanda, thanks. That's a great question. And first, I love this job I have, sort of at the crossroads of all these businesses that were merged. So we're going to make a connected and more safer aviation world and a smarter, more agile defense world all put together. And it's kind of amazing. 60,000 engineers, 40,000 patents. This is going to be a pretty great company, and it's going to be a company that wants to work together because basically engineering and technologists love working together.
Makes sense. Can you share a few examples of the work?
Sure. First of all, one of the things you want to think about is from a technology standpoint, you think hardware and software, right? So let's just talk about hardware for a second, and then we'll get into software. But we build big deal products. We build engines. We also build engines for military and commercial use. We build missiles that go a mile per second, radars the size of buildings, and radars that fit on your lap. So at the end of the day, from a component all the way up to a system level, we deal with technologies that are handling things that are very hot. So let's just say, you want to have a hypersonic missile move at a mile per second, but the propulsion requires temperatures, extremely high temperatures, materials, coatings to deal with those temperatures. Well, the same thing is true for the hot side of an engine. You're dealing with thousands of degrees, and that hot side of the engine is more efficient when it can run hotter. So these basic materials problems, coatings problems that are being solved in our missile plant and also being solved in our jet engine plant. And so the engineers themselves, scientists, are solving some of the exact same problems. They get to work together and learn from each other. And in many cases, whether it's in components like materials, power, thermal management, at the end of the day, when you think about advanced technologies, not just the materials research or the semiconductors being developed. In many cases, we start with components or materials and work them all the way up into systems like missiles, which have electronics, aerodynamics, and so on, or engines where you're delivering an engine that's going to last for decades. At the end of the day, we do everything from design, initial concept, all the way through to the sustainment and life cycle.
So what benefits will Raytheon Technologies bring to the customer?
Well, that's another great question. Our customers expect us to bring solutions to problems and issues that have not been invented yet, but we'll invent them, we'll reduce them to practice, we'll put them into products, and we'll sell them. So we're creating the science that has not been invented yet, and we're bringing it to our customers. So that's the first. We solve the hard problems. Secondly, we've got to make them producible. So we have a whole life cycle from design through our plants, all the way through, and we're pushing the state of the art of what's called digital thread or digital strategies. So our factories, our designs, as well as our sustainment are all controlled through a digital model for our design, all the way through the architectures which run it through the digital strategy. So we're all connected. In doing that, our customers see it faster, cycle times are lower, and at the end of the day, it's an affordable price. It's something where we can drive down the cost of our systems because of the way we're designing and building them right now in our leaner factories, which will have a step function in cost reduction. And that's what they expect. They expect to buy the future missiles or the future radars or space systems at a step function lower, not just incrementally lower. And do it faster. Take it from years down to weeks. Like with additive manufacturing, instead of taking a long time to build something, you can do it in days. And it can be put in space or used in an underwater vehicle. So I think we're seeing in today's environment, technologies are changing in a way that I think people will look back today and say, wow, that's when the beginning of real implementation of machine learning, or real implementation of additive manufacturing, because we're here today. And one of the things that people ask me all the time is, why now? We've been working on these kind of things in the labs for 30 years. People have been doing doctoral theses on additive manufacturing or neural networks 10 years ago. We're able to right now through our models and our high power computing reduce it to practice now. And you've seen that in lots of articles out there from optimizing battery technology and so on. You now can do this kind of optimization where it would take humans forever, where they can actually reduce it to a design that will work, and we can implement these technologies. Think big software, big data.
Well, thank you so much for sharing all this with us. We're excited to continue following the advancements, to come from Raytheon Technologies. I appreciate your time today, Mark.
Yeah, I do too. And I appreciate your time. One of the things I would say is, as in closing, um, when you take 60,000 engineers and you have them start working together, we want them to all be safe in this COVID world.
Right.
They're also dying to get together in a room with a whiteboard and solve more problems. So, at the end of the day, intellectual property and what we do is important. I always say we kind of sell neurons. And so we keep our people safe, but we also look forward to a day when they're all sitting in a lab together again.
Absolutely.
So thank you very much, Amanda, and have a great day.
Thanks, you too.